So can you see the screen?
Yes, I can see second screen.
Okay. So given continuous CT signal XT in figure A and discrete time signal XN in figure B, sketch one. You want to sketch this. You're given XT. So this is what you're given this. Okay. You're given right here, same thing I have redrawn here. Okay.
Okay.
So now you want to sketch the YT. Want to sketch YT is equals to XT.
XT, UT.
Plus X minus T UT. Okay. We can do this part by part. Look one at a time. Look at this first. Look at this one first, and then we look at this one first. Okay. So let's try to sketch this part first. Okay, this part here. Okay. XT okay, that's XT. And then you are multiplying that XT by UT. So you're multiplying, you're going to multiply this XT by UT. Okay. Let me copy and paste that again. What is UT means? What this UT is telling you, the UT is telling you T is equals to greater or equal to 0. That's all it's telling you. Okay. So it's just telling you like all this gone. Okay. For T, this is XT UT. Okay, move this aside. Can you see? Can you follow this?
Yes, sir.
Okay. Now you look at this part. Now you look at this part. This part is telling you you have a minus sign here, right? For example, we look at the signal first. This minus sign here means you're going to flip the signal around the vertical axis. You're going to flip the signal around the vertical axis. What it means is minus T. Minus T means this will go, this is the whole thing is like a flip around the vertical axis. This is the vertical axis. So you're going to just flip around it just like if you rotate it. For example, let me push this here. Keep the original signal in view. That's the original signal, right? That's for positive T, XT. So negative T, you're going to have. So anyway, by the way, I'm going to call this, put this in red color. Okay, that's what's going to happen. You just flipped around this side. I guess you guys can see what happened here. Can you?
Yes, sir.
Yes,
Can
sir.
see.
Yes, sir.
Okay. Now you go back here. You already done this part of it. Now what this is going to do? This is going to let me go and look at the question again. This is x minus t ut.
So x negative t.
So now you're going to have ut, right? Just ut. What ut again? Ut is telling you the signal only exists in this domain for t is equals to 0 greater than 0. So therefore you can delete this part, right? Right. Okay, guys.
Yes, sir.
So next, what we can do, we can. So now what you can do, you can just add them up. Let's say I'm just going to add these signals up. That's what he's telling you. Just add them up. xt ut plus x minus t ut. So you're going to add these two things up. So if you look here at 0, this is 1 and this is 1. 1 plus 1 is 1 plus 1 is
2.
2. One plus 1 is 2. So therefore, you start from here 2. At this point here, 1 plus 1 is how much? Also, right? 2 is 1 plus 0. Sorry, here is 0. 1 plus 0 is 1, right? At this point, at t equals to 2, 2 plus 1 is 3. Am I right?
Yes, sir.
2 plus 1 is 3. Two plus is 3 right here. Okay, yeah, if you look at this very carefully, there are two values here at this point. And the middle point, if you look at this carefully, there are two values here. There's a, this is at time t equals to 1. The signal is 1, and then it suddenly jumped to 2. Okay?
Yes, sir.
Do you guys note that? So therefore, at this point here, 0 plus 1, 0 plus 1, you got 1. Okay, for this signal here, 0 plus 1, you get 1. For this part here, 0 plus 2, so it's going to give you 2, right?
Yes, sir.
So that's going to be a jump also because of this jump here. Okay. Any question?
No, sir.
Yeah. This is a discrete time signal. A discrete time signal. Yn is equals to x3n plus 1 times un. x3n plus 1 times un. x3n plus 1 times un. x3n multiplied by un. Okay, to begin with, this is telling me that n must be greater or equals to 0, right? Right or not? If that is the case, then we don't have to consider all the signal that's below 0, right? So this part here, this part just telling me that this is use of n is greater than, that's all he's telling me right now. Okay. Maybe you can just call this use of n. Use of n. Now you look at this part here. Now you start evaluating, since you know your signal is only exist only for n greater or equal to 0. And so you start evaluating your signal from n is equals to 1, n1, n2, n3, until n3, because we have signal here until n3. N is equals to 4, we don't worry about this because at n is equals to 4, the signal is 0 here. When n is equals to 4, the signal is 0. So you don't have to worry about that. So when n equals to 0, y0 is x x3. I'm just plugging in into the equation. 0 plus 1. The signal is greater than or equal to 0, okay? So at y0, x is 1. If you come and look here, at 1, what is the amplitude of the signal? This is 2, and this is 1, 1. At x1, what is the value of the signal? It's 1, right? This is when x equal to 1. This is when n is equal to 1 and
Okay.
n is equals to 1. So at that point, the signal value as 1. So therefore it's 1. And then you try to evaluate the next one. Okay, we try when n equals to 1, you plug in 1, y1, x 3 times 1 plus 1. So that's going to give you x4, right? When n equals to 4, what is the value? 0, right?
Yes.
So it's 0. So when n is equal to 2, similarly, y2 x7. So above here, above this value, it's 0 at 5, it's 0 at 6, it's 0 at 7. So it's going to be 0 at 4 and above, it's going to be 0. So there's no point of evaluating anymore, correct? There's no point of evaluating anymore. So y0, the only answer is y0 is equals to 1. So in the timeline, it's going to be just 1. Usually we give you this formula, right? Energy of a discrete signal. Energy of a discrete signal is given by this formula. We usually give you all this formula. You don't have to memorize anything. Minus infinity to positive infinity square. So that's the formula to find the energy. Okay, xn is given, your xn is given as a to the power of n use minus n. And a is given as greater than 1. And also the hint, we've given you a hint. The hint I gave you during the test to tell you 1 over a is less than 0, less than 1. So now you just take this and plug it inside here. Take this and put it inside here. So E is going to be a to the power of n. Now, this part is telling you that P is less than, P is less than or equals to 0, right? Am I right?
Yes, sir.
Okay, that's all it's telling you. So you can go ahead and therefore you can go ahead and change this lower minus infinity to 0. Sorry, 0 to minus infinity. 0 to lower limit is minus infinity, upper limit is 0. Minus infinity, upper limit is 0, right? Okay, follow.
Yes, sir.
Forgot this is squared. So what you're going to have inside here is like that, right? Any question on this? So this is e to the power of so now you can multiply the inside and the power inside the modular sign and outside the modular sign, it becomes 2n. Okay, now it is possible to change this to minus 2n. By doing that, if I reverse what I do, instead of, I can change this limit from 0 to infinity. If I do that, because I'm having a change of sign here, I change this sign, and then I change this sign. So it becomes even. It's the same thing. Any question? I know after lunch you guys are sleepy, right? I'm also. But do I have a choice? Can again. So now I can rewrite this as 1 over a to the power of absolute value, or can just bring the 2 in. Okay, I can write this like that. Okay. 1 over a squared is still less than 1. If that is so, one over a squared is still less than 1. Okay, there's a mistake here. It's supposed to be e. Now e can be written as e 1 over a, the whole thing n. And again, note that is less than 1. Okay, now if that is so, then I can use one of these formulas to solve the problem, right? See, I can use the first formula. K is going from 0 to infinity. See, K is going from 0 to infinity. A to the power of K. The condition for doing that is the A must be less than 1. So in our problem here, the A, this is actually A. The whole thing here is A. And of course, you know, A is less than 1, according to the formula, okay? So therefore, I can use that formula. So therefore, it's going to be 1 over 1 minus 1 over A squared. Multiplying top and bottom by A. Is going to be energy is finite. Since the energy is finite, so power, average power is 0. Okay, any question?
No, sir.
No, sir.
Again, you know, this question is again, it will be asked in the midterm. So make sure you get the concept pretty good. Causal yt is equals to txt. Is it causal? A system whose output, first we define causality. Causality, the signal is causal if it has an out, if the output depends on present or an past input. And not future. For example, yt is, you can try any number. For example, if you, for an output when t is equals to 1, okay, so the output the t is equal to 1 is 1 times the input is also 1. So this is tells you that the output always depends on okay, present means if you put 1 here, it's going to be 1 there. If you put 2 here, it's going to be 2 there. If you put 0 here, it's going to be 0 there. Okay. So therefore, it's causal. Therefore, it is causal. Is it stable? What happens when t goes to infinity? When t goes to infinity, why infinity will also go to infinity? Therefore, it's not stable. Because why it's infinity? This the t will keep increasing, right? As you increase t will keep on growing. Any question? Is this linear? Not stable. Is this linear? Let's try and see. If you input a1 x1 t, then the output will be y. Sorry, the output will be, if you input, this is going to give you an output of t a1 x1 t. Which is, can be written as a1 t x1 t. If you put another input a2 x2 t, it's going to give you t a2 x2 t. Which can be written as a2 t x2 t. Individual input, if you look very carefully, this is you look carefully, this is, you can call this y1t. You can call this y2t. So the individual output is producing individual input is producing an output that's A1 y1t. This input is going to produce A2 y2t. Right? You can just write this A1t x1t produces an output of A1 y1t. So what will the sum of these inputs will produce? Right now, let's say the input is, this we call this input 1, input 2, and then input 3. Input 3, now your input is sum of individual inputs. Okay, what will be the output is going to be T sorry, the input is so the output is going to be T A1 x1 T plus A2 x2 T. Which is going to be A1 T x1 T plus A2 T x2 T. Are you guys sleeping or still listening?
Yes, sir. Listening, sir. Listening.
Okay.
Yes, sir.
It's okay if you guys are sleepy. You know what we can do? It's afternoon after lunch.
No, sir. I haven't taken lunch yet.
Okay. So now you can see like the sum of individual output creates sum of individual input creates sum of individual output. Therefore, actually I myself also sleeping. This is a recording. Plus A2 Y2T. The sum of individual inputs create an individual output. So it's linear. If you get an additional term like plus or something else, another term, say a t squared or something, then it's not linear anymore. So therefore it is linear. We want to do so you want to find the convolution y of n or x of n. These are discrete time signals. A given xn use of n. X of n is use of n. And then the h of the other signal, hn, and it's u n minus 4. The first thing we want to do is we want to change variables. Change variables. In one signal, you let x, it can be any one of this thing. Let n equals to k in the signal. So therefore xk is equals to use of k, uk. UK is under lockdown for 6 months. Okay. And then on this side, h, you replace, on this side, you replace the n with k. Here, you replace the n with, you replace the n with n minus k. Therefore, h n minus k is going to be u. Okay, you replace the n with n minus k, correct? It's going to be minus k plus n. So you're replacing the n with n minus k, or just k, or same as minus k plus n, right? Minus k plus n. Okay. So now what you need to do, you have to do a sketch each one of these. First you sketch x of k. X of k is a signal, a discrete signal that start at k is equal to 0 and going up to infinity. Maybe don't go too far because we need space on the other side. Okay. What do you say? Okay.
Okay, sir.
Okay. Next, you sketch a x of k. Sorry, h of k. I mean h of n minus k. Okay, you sketch part by part. You don't have to straight away jump into h minus k. You go step by step. Then you can see how to sketch it. First, you sketch h of k. Okay, h of k, you know, a signal. In this case, h of k is a signal. H of k, right here, is just u n minus k minus 4, right? A signal that starts at 4, 0, 0, 0, and then it starts at 4. Okay. Sketching h of k, any problems?
Okay, sir.
No problem, right? Next, you sketch. What do you want to know? Now you sketch h n minus k. Or before doing that, let's sketch h k plus n. Sketch k plus n. hk plus n. Plus n is going to be minus n here, right? Any question?
Also,
So how are you going to sketch hk how about if I change the plus k to minus k? What's going to happen here? You're going to flip the signal about 0. Okay, you're going to just flip the signal about the x equal to, this is like a k is equal to 0. So you just flip the signal about k equal to 0. So what will happen is, Let's say your positive numbers will change sign. Let's say if you have a minus, if we have 4 here, I'm just going to give you an example. If this is, let's say 10 here, and if you flip, it's going to become minus 10, right? So it's going to change sign, isn't it? So therefore, when you flip, 4 minus n becomes n minus 4. Okay, there you go. So that is really your what you're looking for. That is minus, okay. Okay, that's how we have the final. And now what are you going to do? We're going to slide. So this is the one signal that you have got sketched earlier. Bring it over here, put it here. Okay, put it somewhere here. Then you're going to take the other signal. You're going to slide over like this. So you're going to start from here probably. You're going to slide when there's just two, when the xk and h minus k plus n, they overlap like this, overlap. Okay, right now there's no overlap. Sitting like this. Overlap means, what I mean by no overlap, you see right here, this is one, all these are one. For example, so all these are amplitude one. So right now when they are not overlapping, 1 times by 0 is 0, correct? For n less than 4, less than 4. I mean, if you look here, for n minus 4 less than 0, there's no overlap. I mean, this is same as saying that n is less than 4. When n is less than 4, there's no overlap. I mean, in this case, k is also less than 0. So therefore, y output, y and no overlap, so therefore, So I'm just doing this step by step, showing clear steps. So it might look as though the problem is difficult, but because I'm doing a lot of steps. So now you start overlapping them. Let me put this a little bit higher. Okay, now you overlap. You keep sliding over until all of them overlaps. Until it overlaps. Okay. Now the time domain we are looking at is n minus 4. Minus 4 is greater than 0, which is equivalent to saying that n is greater than 4. In this case, which is equivalent to saying k is, which is equivalent to saying that k is greater than 0. K is the lowest value 0, right? Greater than 0. And this one is going up to infinity, but less than infinity. The y of n is the summation as k. What is the lower limit we are looking at? The lower limit. When they overlap, what is the lowest limit? The lowest limit, which one controls the lower limit? This one or this one? Okay, the lower limit is controlled by this, because there's no signal below 0. Zero signal, 0. So therefore, no matter whatever you multiply with it, it's going to be 0. So the lower limit is 0. So upper limit is controlled by what?
N minus 4, sir.
Yes, n minus 4, because depends on the value of n. N can be anything. N can be 100, 200. So that's going to determine the upper limit. This one is going up to infinity. So therefore, it can go forever. But this is n minus 4. There's a finite value. It's going to be 0 after that. So therefore, n minus 4 is going to control the upper limit. Okay, what is the, if you can see the overlap, signal 1 times 1 is 1. K is equal to 0. This is 1 times 1 is because this amplitude is 1. This amplitude is 1. Therefore, in this lower to upper limit, it's 1. How are we going to evaluate this? That is going to be upper limit minus the lower limit, okay, plus 1. You need to put plus 1, otherwise you will lose counting. For example, if you have signals overlapping, right or not? You say you're having a signal overlapping 1, 2, 3, 1, 2, 3. Then you will say, okay, k is equals to 1 to 3, right? Then if you go, it's going to be 1, you say, then you evaluate 3 minus 1. It's going to give you only 2, right or not? But actually there are 3 of them. See, 1, 2, 3. So you're going to miscount. That's why you have to add 1. So n minus 3. Sorry, n minus 3. So n is going to be greater than 4, but less than infinity.